Using the cubes patterns can be tricky, so let's just run through another example. We're going to factor y to the third minus 27. So we see two terms, and we see an exponent of 3. So we're setting up boxes with an exponent of 3 on the outside. Into the first box, it's going to be a y to the third power equals y cubed, and 3 to the third power equals 27. When we get to this number 27, how do we know that it's a 3 that goes inside the box? Well, I guess perhaps some of these numbers, and with a little bit of experience and getting used to seeing these numbers often enough, you'll know that 3 cubed is 27 and 4 cubed is 64. If you're not seeing them right away yet, then I think the easiest thing to do is to try repeated multiplication. There aren't too many numbers out there to have to try, so if we're looking at a number like 27, I would try, well, 2 times 2 times 2 is 8. That's not it. 3 times 3 times 3 is 27, so there it is. We just found it, that it was a 3 that we need in the box. And if you search for it that way, it doesn't usually take too long to find out what number we need. Okay, the other thing to notice that we have two terms that are cubes is what is the sign that we have between them. We could have either a difference of cubes, which is what we have here, or in a second we're going to see we can also have a sum of cubes, an add symbol. So there are different patterns, one pattern for a subtract and one pattern for the add. So we need to make sure we're using the correct pattern. If we see a subtract, we need to find the pattern that has a subtract between a cubed and b cubed. These sets of parentheses represent how we're going to write our answer. So we are going to start with one set of parentheses, and remember that what's in our first box is the a, and in the second box is the b. So a minus b for this problem means y minus 3. We set up a second set of parentheses. A squared is going to be y squared. We'll have an add. A times b is y times 3, 3y. And another add, and then the last term is b squared. So it's 3 squared, and we should write in 9. It's maybe not the best form to leave it as 3 with an exponent of 2. We should simplify that and just write the number 9. And there's our factored answer. Here's another example to look at. X cubed plus 64, another binomial where we see an exponent of 3, so we're looking at cubes, but we have an add, so we have a sum of cubes. Now you might think back to when we were looking at squares, we said an add made that binomial prime, and that's true, but it's only true for squares exponent of 2. So when you see an exponent of 3, definitely, absolutely, adds and subtracts, we can factor both. Okay, let's look at the pattern for factoring a sum of cubes, and it's very similar to the pattern for factoring a difference of cubes. Both start in this first set of parentheses, have a and b, only difference is the signs, and in the second set of parentheses, both have a squared, both have ab in the middle, both end with b squared. So they are identical patterns aside from the signs. So when it's a difference of cubes, we have the same sign in the first set of parentheses, a subtract between the cubes, a subtract between a and b in the first set of parentheses. If we have an add, then we'll see the same sign and add in that first set of parentheses. The signs change in the second set of parentheses. Here we'll have the opposite. So if we are dealing with a difference of cubes, we'll see the same subtract in the first set of parentheses, but an add in the second set of parentheses. And when we start with an add, we'll see a subtract in the second set of parentheses. Back here, this will always be a plus. So to help me remember the patterns, I have to memorize the a and b are in the first set of parentheses, and in the second set of parentheses we have a squared, AB, and B squared. And I don't worry about the signs because I have something helpful for remembering the signs. I think of the baseball team San Diego Padres, SDP. And SDP tells me same, different, plus. And those are my clues for the signs. So if we have a subtract, then my signs are same, the same sign, different sign, and the last one is always plus. If you're starting with a sum of cubes, our signs are the same and then different, and the last one is always plus. So just try to remember the a, b are terms in the first set of parentheses, the three terms in the second set of parentheses, a squared, ab, and b squared, and then use SDP to remember the signs. So let's proceed with this example, x cubed plus 64, and we're going to use the pattern for sum of cubes. We are starting with these boxes with exponents of 3 and thinking, what in the first box? We'll need a regular x, and a 4 to the third power is 64. We'll begin filling in the pattern. The a plus b is going to be x plus 4. In the second set of parentheses, a squared is x squared, and then we have a subtract, and then a times b, x times 4 is 4x, an add, and b squared is 4 squared. 4 times 4 is 16. Here are two problems for you to try. They are binomials and they're both cubes. Notice that we have one difference of cubes and one sum of cubes. So we're going to use those cubic patterns, one of each kind. And so watch for those signs. Put the video on pause, take a few minutes to work these out. When you're finished, come back and we'll check out the answers. For this first binomial, I've set up my boxes with exponents of 3, and in the first box, x. In the second box, it's a 1, because, well, 1 times 1 times 1 is still 1, so when we see a 1 here, it's a 1 to the third power that's equaling that 1. Filling in those boxes helps us when we go to fill in the pattern. Since it's a minus, look at our signs. They're the same sign, minus, minus, same. Here we see that they are different, and the third sign is always a plus. Okay, a minus b is going to be x minus 1. A squared is x squared. A times b is x times 1, 1x. And our third term here is b squared. 1 squared, 1 times 1 is 1. I want to point out about this sign. When we are working with these cube patterns, you really can't ignore the sign just as long as you use it to figure out which pattern to use. I don't want you to think that a negative 1 should go into the box. And I can understand why you would think that, and I even agree with your thoughts that say, shouldn't it be a negative 1, because negative 1 to the third power equals this negative 1. And I say, in the boxes, don't ever throw in a negative number, just keep it positive. I think that's the easiest for us to work with when it comes to filling in the pattern for our answer. Okay, let's do this other example, x cubed plus 216. Set up the boxes with exponents of 3. So 216, I know about 4 times 4 times 4 is 64. So I could try 5 times 5 times 5 is 125. Or maybe I know that it couldn't be 5 since this doesn't end in a 5. It's actually 6 to the third power. 6 times 6 times 6 equals 216. So an x in the first box, 6 in the second box. We have a sum, so we're using the pattern for a sum of cubes, and a plus b is x plus 6. There's our a squared. We're using x squared. A times b is 6x, so there's our 6x. And b squared is 6 squared, 36. And check out our signs. We're using the San Diego Padres rule, SDP, so the signs are the same, different, and the last is always plus.